talking about parabolas. You guys are going to be able to analyze, graph, and write equations of parabolas. Just like how you were able to do for circles, you guys are going to be doing the exact same thing, except this time for parabolas. So to start, at the very top of that conic section parabola sheet, you guys are going to write in this formula here. This is one of the two formulas that you will need to know when it comes down to parabolas. 4p, y minus k equals x minus h squared. When you have an equation that's written in this format where your x's are being squared, you know the parabola is going to open either up or down. So when the x's are squared, like they are here, it's either going to open up or down. Your vertex is going to be located at hk, whatever those values are. And making a quick change right here, let's make this 4p, and let's make this 4p. If this value here, whatever p is, you multiply by 4. If it's greater than 0, it's going to open up. If it's less than 0, it's going to open down. It's almost like what the a was when you were looking at standard form of a parabola. Now the focus is a point that's located on the inside of your parabolas. And how you find the location of that point? Well, it's still the x-coordinate of your vertex. And then you're going to take your y-coordinate and add whatever the value of p is to it. The directrix is a horizontal line, a horizontal dotted line that's on the outside of your parabola. That's going to be the equation, what? Horizontal lines have an equation that starts with? Y. It's going to be y equals k minus p. So whenever we're given a parabola, we need to determine, okay, what exactly is the value of p, because that's going to tell us our focus and it's going to tell us our directrix. Okay? And then we also need to figure out whether it opens up or down for graphing purposes. It could open left or right, though. Not just up and down. That was algebra 2. We're in pre-cal now. So it's going to open left or right if the y's are being squared, as you guys can see here. So it's either going to open left or right. The vertex is still going to stay the same. It's still going to be hk. So whatever those values are, those are still going to be there. Change this again. If 4p is greater than 0, then we know it's going to open up to the right. So it's going to look like this one here. If it's less than 0, it's going to open to the left. The focus is still going to be located where? Where's the focus located? On the inside of the parabola. So to find it, we're going to take our h-coordinate, the x-coordinate of our vertex, and add p to it. The y doesn't change. So it's almost like the opposite of the other one. The directrix is now going to be a vertical line. Vertical lines start with x equals, and it's going to be h minus p. So let's take a look at an example here. We have a y plus 5 squared equals negative 12, x minus 2. Based off of this, what's being squared? Our x's or our y's? Which means it's going to open either left or right. So I'm going to go ahead and I'm going to write in the general equation. That is rain. We're going to write above that just the general equation so we can just have that as a visual. Okay? So now let's find the vertex, okay? Remember the vertex of the parabola was hk. What's the value of h? 2. And what's the value of k? Negative 5, okay? As we can see in the formula, it's y minus k. So the only thing to make that plus 5 even exist is if we plugged in the negative 5 for k. So that's where our vertex is located. Now our focus... Remember, it's that point that's located on the inside. If you need to look back at your the one sheet that has all your formulas on it, since this opens left or right, are we adding p to the x value of the vertex or to the y value? To the x value. But the question is, what is p?
3.
It's negative 3. You got to set 4p equal to negative 12. A quick divide. P is equal to negative 3. So I'm going to take that number of p, which is negative 3, and I'm going to add it to the x value you guys set. So it's going to be 2 plus a negative 3, negative 5. And what is that?
Negative 1, negative 5.
Negative 5. Since 4p is negative, which way specifically does this open? It opens to the left. Very good. Now the axis of symmetry. If you're like, Ms. Anderson, we didn't have axis of symmetry in our booklets. You deceived us. No, I didn't. Okay? You guys remember axis of symmetry from when we did quadratics back in first semester?
No.
Yes, I do.
Well, you should remember them from last year, Algebra 2 or Algebra 1. What does the axis of symmetry do?
I don't know. I got this.
It splits it in the middle. The axis of symmetry goes straight through the vertex.
Well, that makes sense.
Okay? Now, if this is a parabola, and I'm just doing this just for the sake of having the visual here. We're going to graph it specifically. Don't copy this down. I'm just doing this as a reference. If it's opening to the left, our axis of symmetry, is it a horizontal line or a vertical line? Horizontal. Okay? If it's a horizontal line and it's going to cut through our vertex, is it going to be the x-coordinate of our vertex or the y-coordinate? The y-coordinate. So our axis of symmetry is going to be y equals the what coordinate again? The y-coordinate of the vertex, the k. So if you want to add that in there, add that a part of like your notes that axis of symmetry for parabolas that open left or right, or y equals k. Exactly. Okay? Now we're going to identify the directrix. For parabolas that open left and right, the directrix is x equals h minus p. H minus p. What's 2 minus a negative 3? A positive 5. So x equals 5 is our directrix.
Will they always equal each other? Or does it
One's a positive, one's a negative. So now we're going to graph everything. Did I do a good job of gluing in the graphs? Is this the graph you see on your first one? Mm-hmm. Good stuff. Okay. So our vertex located 2, negative 5. Be careful. Each line is actually represented by 2. So 2, negative 5 is located right about here. I have a focus of negative 1, negative 5. Oops, that's not negative 1. And the directrix, which is a vertical dotted line, is at x equals 5. And that is a job well done. Because the parabola, if it does open up to the left, then the focus should be on the inside, the direction should be on the outside, which this does indeed verify. So all I'm going to do is I'm just going to draw a parabola that shoots off left and right. Ms. Anderson, are you going to be concerned about the points, exactly where they are on the parabola? No, I'm going to be looking for the focus, I'm going to be looking for the directrix, and I'm going to be looking for the vertex. And hopefully you have it opening the correct way.
Should we draw the axis of symmetry?
No, you don't have to draw the axis of symmetry. That's probably just going to throw you completely off. When I look at your work. Yes? The directrix is kind of like what the focus does. It's anywhere on that line, any point that's on the parabola is equal distance from.
Oh, sorry.
So it's all about a spacing thing. That's what makes the parabola so symmetric. So. Questions? It's more about knowing which way it opens, the formulas, and then making sure you can match everything up. Let's write down this one on the next graph.
Which matches?
It matches. That's what's good. So I did a good job there. What's being squared?
The x value.
Which means it opens either
Up or down.
up or down. What's P? P is 2. Remember, you have to set that number equal to 4P first. P is 2. So since it opens either up or down, more specifically, this opens which way? It opens up.
Wait, how do you know if it opens down?
If that's negative, that's how you know it's going to open down or to the left. The vertex. Be careful. I can see a lot of students doing this, putting -3, 4. Okay, you got to be careful. Where's H?
Oh,
It's going to be 4, -3. Be very careful, okay? You got to figure out where is X minus H, because the H goes first. I'm going to let you guys find the focus, the axis symmetry, and the directrix on your own, then we'll come back together to graph it. Shouldn't be too bad once you know the value of P and you get your vertex laid out, since this does open up, and it is 4, -3, right? Okay?
It's actually all the way down the bottom because
Oh, the Y's go by 1. Oh, tricky. All right. Where's our focus? It's 4 what?
-1.
4, -1. Very good, because you take the K value of the vertex and add P. Very good. So 4, -1. And your directrix, I'll go back to axis symmetry in just a second, is going to be Y equals -5. And the axis of symmetry is what? X equals 4. Okay? So my parabola is going to open up from the vertex. Where did?
Yeah, how do you,
Remember the formula for directrix.
oh, I need to learn something.
And so since K is already -3 and P is 2,
Oh, it's -3.
it is -3. Yes.
Oh my gosh.
-3. The Y corner of the vertex.
Wow.
Question.
Why is it -3? Because it's opposite.
Because right here in the formula, it's Y minus K. So in order for it to be a positive, that meant we had to plug in a -3 in order to make that a +3 in the formula. So it's always the opposite. The vertex is always the opposite in that formula, okay? Here's the next example. It is Y equals a -1/4 x squared plus 3x plus 6. It says that we're going to write that into standard form. We're going to write that into standard form. Then we're going to identify all the good stuff and then graph it. Okay? Oh my goodness, y'all like, ugh. Just answering this problem.
Wait, why do we, oh.
What did you do? How many more units do we got left?
Okay. We are going to need to complete the square. Okay? And I know some of y'all are looking at that fraction like, I do not want to work with that fraction. Every time we have a fraction, you can get rid of it. Multiplying it by 4. Not just that one part that has the fraction, but every single thing. That includes the Y. That includes the 3x. That includes the 6. If you don't like fractions, get rid of them. Multiply this whole thing by 4. So now the equation we're working with is 4y equals a -x squared plus 12x plus 24. Now we have only whole numbers here. And yes, we are going to need to complete the square. With parabolas, it's just a tad bit different, just a tad. you want to make sure that only your x squared term and your x term, or whatever the squared, whether it's y is being squared or x is being squared, that needs to be on the same side alone. Which means that, what do you think we need to do with this 24? Subtract it over. So that's going to be 4y minus 24 equals negative x squared plus 12x. The reason why we're doing this is because we need to complete the square. And if you guys recall from completing the square, you only want your square term and its corresponding variable together on one side. Okay? When you complete the square, this first number needs to be what? How do I turn that to a positive? Multiply everything by negative 1. I need this to be a positive 1. So I'm going to make this a negative 4y plus 24 equals x squared minus 12x. You just can't do it to one term. You have to do it to every single term. Now let's complete the square. I have to take half of what number?
12. Negative 12.
Negative 12. I need to take half of b and square it. What's half of negative 12?
6.
Negative 6.
36.
Squared is 36. What do you do with that number?
Add it to both sides.
Add it to both sides. So that's a negative 4y plus what? 60. What do I do to this side over here?
X minus 6 squared.
You're correct to see.
X minus 6 squared. I basically need to factor it. You guys did some completing the square when you guys were working on your circles homework. It's the same concept. We are. We're just missing one thing. We need to know what the P is. What do you think you're going to do to the left side?
Allow it to.
You want to pull out the greatest common factor.
4.
Not just a positive 4, but a negative 4. When I pull out a negative 4, what's the difference? In the standard form, isn't it y minus k, not negative y minus k?
Now you can just close that number.
What's when you pull out a negative 4 from a positive 60, what does that give you?
12.
15.
Oh,
It would be a negative 15. And that is your standard form. A few extra steps that I probably wouldn't do on a normal key, answer key.
Does that mean P is 1?
P is negative 1.
Oh.
Get your signs. Watch your signs. All right, I want you guys to find all the information. Now that we have the standard form, find all your information. All right. What's the vertex?
615.
Where's the focus?
614.
6 negative 14.
Negative 14.
Whoa.
No,
Whoa.
we're not
That's
614.
not true. It's
Should be 614. What's the value of P?
Negative 1.
Negative 1. And remember, the formula is H, comma, K plus P. Since P is a negative 1, it's technically we're subtracting.
Plus P.
It's so confusing.
Uh-huh.
when you have to
Okay,
switch
I
it.
don't see how you got 14 unless I'm looking at the wrong thing.
15 minus 1.
Make sure that you have the equation for
I know, where'd you get the one?
from here. Remember, to find P, you set 4P equal to whatever this number is.
Oh, I'm not doing that.
And so then the formula is going to be H, K plus P. Since P is a negative 1, it's going to be 15 minus 1. Or 15 plus a negative 1. Axis symmetry is going to be x equals 6.
Yeah.
No, not x equals 6.
Y equals 15.
Now y equals 15.
Wait,
Let's try this again. Axis of symmetry.
X
X equals
X, Y
6.
is
My bad.
X
Equals
X
K?
equals
Something?
X equals
What?
six.
It's X.
Y equals
X
6.
equals
It's
X.
Six.
X equals 6. You said 6 before. It got to be a full equation. X equals 6. Not 16 or 15, whatever,
Or
Or
6.
-6.
or -6. The directrix,
Y
equals
equals
14.
16.
y equals 16. Y equals 16.
It's open.
Do you have that sheet side by side?
Yes.
No.
Are you looking at it? Okay.
Things I looked at it.
Get everything in there. There's y equals 16. Got a lot on this page. The y-axis goes by 2, so does the x-axis. So
6 all the way 15.
6, 15,
And then 6, 14.
right below it.
And then you're good.
So this opens,
Down.
which makes sense because it was 4p was less than 0, so it opens down.
I was well, that's it. That makes sense.
Okay?
I have a question about the directrix.
Question about the directrix.
So does it work kind of like an asymptote to where it will never touch it?
Correct. And to be honest, the directrix and the focus are the same distance away from the vertex. Does everybody see that? Like that directrix was 1 unit away from the vertex, the focus was 1 unit away from the vertex, okay? And it always will work out that way. If we look at the previous problem that we did, okay, the vertex was located at 4, -3. The focus was located at 4, -1, a distance of 2 units. Even though I didn't have the lines, and I know this looks bigger, but at y equals -5, that's still 2 units away from your vertex.
So you can figure out the directrix or the focus from each other if you have one.
Exactly. So you can figure out other pieces of information if you know, say you know the focus and the directrix. You can figure out the vertex. If you know the focus and the vertex, you can figure out the directrix, and so on and so forth. Okay. Speaking of,
Oh
we are gonna. I just wonder there was one more. No, I guess not. Okay.
Yeah.
Now we're going to write equations given these types of pieces of information.
Do we still have to graph it?
We'll graph. Yeah.
It's
Still gonna graph.
Keep the hand.
But it's not like I'm asking you to make a table, which is always a default. If you forget or you can't remember what way it opens, you can at least do a default table and plug in values like we used to.
Oh Lord, that's
Okay.
not enough space for that.
If that's true. Definitely not on this little foldable. It's definitely not enough space. But
I mean, it's not that hard. Plug in 0.
unless it's nasty. All right, we're gonna write an equation and we're gonna graph it. Okay. So we have a focus at 3, -4, and a vertex at 1, -4.
Oh.
Okay? So I have the graph here. I'm going to start by plotting it just to kind of give us a visual here. So 3, this goes by 2. So 3, -4 is the focus. And then 1, -4 is the vertex.
This is going to be going left, right? Yep.
Now remember, is the focus on the inside or the outside of the parabola?
Inside.
Inside. So if this is where my vertex is located, and that's where my focus, this should open what way?
Oh, right.
This should open to the right.
Understood.
And if you're like, wait, how again? Remember, the focus is on the inside of the parabola. So if you have the focus point and then the vertex point, then it has to be opening up to the right in order for the focus to be inside of the parabola.
Can't we tell what the directrix is?
And we can figure out what the directrix is because they're the same distance. The focus and the directrix are the same distance away from the vertex. Okay? How far is the focus away from the vertex?
2.
It is 2 units.
Negative. Negative 1.
It's 2 units away. So then the directrix is going to be that same distance. 2 units away, which will put us at -1. So x equals -1. That's the directrix. Well, I'm writing the equation.
Well, I mean, we already graphed.
Okay? So, since this opens to the right, does that mean my y's are being squared or my x's are being squared? Your y's. So the general formula is 4p x minus h. And we know this is this formula again because it's opening to the right. So that means our y's are being squared. Now technically I know all my information, don't I?
Yeah.
What's my vertex?
1, negative 4.
1, negative 4. So I know this is going to be y plus 4. Since k is negative 4, I just plug it in. Over here, I know this is x minus 1 because my x coordinate of my vertex is 1. What's the value of p? We just talked about it. It's positive, yes, but what is p?
4.
What is it? It's 2.
Oh, how many? It's over.
It's how far away the focus is from the vertex or the directrix is from the vertex.
How do you make a note?
So this number right here is going to be 8. Again, p is 2. The distance from the focus to the vertex or from the directrix to the vertex, that's the value of p. Look at the problems from the previous page.
So when did you, yeah, it should be 8, right?
You see how far apart the vertex was from the directrix?
Yeah.
That was 1, correct? And it opened down, so we knew that it had to be negative. Look at this one. The distance from the focus to the vertex was 2. Wasn't, there's it, p is 2.
It makes sense.
Why didn't we do that?
So there should not P technically be 8.
Over here. No, p is the distance.
Oh, well, our P is 2, but I meant, like, shouldn't it be
That
8?
number should be 8, yeah.
Or is it-
This one right here, this one was 3 units away. It was negative because we were opening to the left. Okay?
So we can find our P, and then we just have to multiply by 4.
Exactly.
We have that.
So much less space required if you're doing graphing first.
All right? Oh, are we good?
Yeah.
Let's take a look at this one. I want to see if you guys can figure this out real quick, okay?
Oh, yeah.
Oh,
Okay.
good enough.
I normally get X's and Y's and stuff.
I think I know here.
Oh, yeah, negative 3.
To Buffalo.
Not anymore.
I go to Buffalo, like,
How many volumes are just
I mean, you're
One.
I'm assuming.
when did you get for your game for your
3.
All right.
It should have already been.
So hopefully maybe you start by graphing some things like the directrix and the vertex. And so by doing this, we can figure out that it opens which way? It has to open up. It couldn't open down because the parabola doesn't cross over the directrix. So it has to open up. Okay? And because it opens up, does that mean my x's are squared or my y's are squared?
Your X's.
My x's. So that's the formula. Right?
Yes.
Okay. So, what's p?
3.
And you find p by
Counting the space between the directrix and the parabola.
exactly the distance between the vertex and directrix. That's 3. The last problem we did between the focus and the vertex, it's the same number. Same number, okay? So if p is 3, then this number up here is going to be 12 because we plug in 3 because p is 3. Then it's going to be y minus 4 equals x,
Plus 2.
Square.
and that's our answer. That's our equation.
Christmas. You're not human.
All right?
Now you can find focus.
We don't need it,
Wait, what?
but we could.
Wait, we don't need
It's
that.
3 away from the vertex.
It's 3 away from the vertex. So if the vertex is located at -2, 4, my focus is going to be at
Negative 2, 1.
-2, 7.
Oh,
So all we have to do is
Because we're just writing the equation.
Okay.
I mean, I already graphed it, so I mean, I don't know why I didn't get that right.
I don't know why. Found the focus.
Okay. Write this one down.
It's not in there.
All right, we're looking at this one. We have a focus at 2, 1. It opens left, and it contains the point 2, 5. Now, 2, 5 is a point that's on the parabola. When it says it contains a point, that means the parabola itself has that point 2, 5 on it. Okay.
Are we setting up a table for this?
We are not setting up a table. But what we're going to do is we're going to use the fact that we know which way the parabola opens, and we're going to use that point to help us figure out a piece of information. If it opens to the left, does that mean our y's are squared or our x's are squared?
Wise, right?
It means our y's are squared. So it's the
Okay, so
formula
using-
4p Okay? Right? Yes. Okay. Good. So, from here, we know, since it opens to the left, look back at that single sheet. What was the formula for your focus? If it opens to the left or right?
H plus P, K.
Everybody see that right there?
Oh, never mind.
So because the focus is the formula H plus P, comma K, we know what the y-coordinate of our vertex is. It's 1. It's this number right here. Does everybody see that? Okay? So we can plug that in. That's going to be K. So we have a y minus 1 squared.
There's so much to pay attention to.
There's a lot to pay attention to. Okay? Like this one probably is going to be like the hardest type of question that you're going to get when it comes to writing the equation. Because we don't know enough to just write it from what we have. Now, we know that H plus P equals 2. We know that, correct? So whatever the x coordinate is of the vertex and whatever P is, we add them together and we should get the number 2.
Oh. Yeah, but once you get negative.
Okay? All right, hold on. We'll worry about the negatives and stuff in just a second. Okay? Now, from here, what we can do is we can solve. No, we're not going to plug anything. What we're going to do is we're going to solve for H here. We're going to solve for H by doing what?
Having a... Yeah, that's...
Subtracting P. Now, the reason why I'm doing this is because we do not have enough information to just plug everything straight in. All we have is a point on the parabola, the y-coordinate of the vertex, but not P nor H. But we do have an equation that allows us to solve for one of the variables, which means that I could take this 2 minus P and plug it in for H.
Oh.
Stay with me, okay?
Wait, we have to foil the other side.
Wait, okay, here that thing comes again where y'all ask me like 6 questions at one time. Let me write this down first. Okay. Questions? Now, I got 2 P's here. That's good. I can plug in 2 and 5 for X and Y. It's a point on my parabola. Just like if you had a point on a line, you can plug those in for X and Y to see if it actually, equals. We can do this here as well. That's 4P. I'm going to plug in 2 for X and 5 for Y. And now I just have one variable that I can solve for, a variable that I need in order to write this equation. Algebra from here. This negative on the outside of this parenthesis needs to be distributed through. So that's going to be 4P. 2 minus 2 plus P. What's 5 minus 1?
4.
I'm going to square that.
16.
Okay. And then what's 2 minus 2 on this other side?
0.
So technically I have 4P times P equals 16.
Will it always work out like that?
Well, it should work out to the point where you should get a nice number.
You could divide by 4.
Divide by 4, what's P times P?
Squared. Whoa, that is not
And 16 divided by 4 is 4.
4.
What do I have to do?
Square.
Take the square root, which gives me plus or minus 2. The question is it positive or negative?
Opens left, so you know.
It opens left, so you know P has to be a negative 2. Now, if you're like, oh my goodness, Ms. Anderson, I'm out of space, don't worry. We are pretty much done. We're going to write our equation. H does equal 4 because I take this P and plug it into this equation back up here. Remember when we solved from the beginning for H? We just found P, and so we can plug it in. What is H? 4. So my final answer, my equation, if P is negative 2, what's this number up here at the front?
Negative 8.
So it's going to be negative 8 x minus 4 equals y minus 1 squared.
Wait, so your H was positive 4 then?
H was positive 4 because I took that negative 2, which was P, and plugged it in. So let's recap real quick. Since it opened left, that's where the red equation came from, the general form. I knew the y-coordinate of my vertex from the general equation for the focus. That's why I plugged in 1 for k. Since h plus p had to equal 2, which was the x-coordinate of my focus, I set up a separate equation and solved for one variable. By solving for one variable, that allowed me to plug it in, and then I was able to plug in the point that it gave me so that I only had one variable that I needed to solve for. And that variable just happened to be P, and I knew it had to be negative because it opened left. That's probably the hardest that these problems are going to get, guys. Okay? We got 2 more. This is the next one. We're not graphing on this one. So that space, that blank space at the top of the right side, that's where we're going to do this problem at. Okay, so knowing that the focus is at negative 2, 5, and the directrix is at x equals 4. X equals 4 is a vertical or horizontal line? Vertical line. So it's crossing at 4, and the focus is at negative 2, 5. Which way does this parabola open? To the left. Very good. Now remember, the focus and the directrix are the same distance away from the vertex. We don't know what the vertex is, but knowing that this is at negative 2, 5, and this one is hitting at 4, what is our vertex?
4.5.
It's at 1, 5. How'd you get 1, 5, Caleb?
You add the 2 x's together and then divide to find the middle.
These 2 right here are 6 units away. Divide by 2. 3. P is 3. That's how far both of them are away from the vertex. And sorry, yes, it would be negative. P is actually, sorry. Because it opens to the left. So then the vertex is the point, like he said, 1, 5. It's 3 units away. The y-coordinate does not change. No positive. Because 4 minus 3 is 1. Negative 2 plus 3 is 1. H is 1. K is?
5.
And P is?
3 or negative 3?
Negative 3. And it opens to the left. So does that mean my y's are squared or my x's are squared?
Y's.
So it's going to be 12.
Yeah, y is x minus 1. That's the formula we have to remember, the 2 versions.
Mm-hmm.
Okay.
Yeah, remember the 2 versions. That's why I keep rewriting it, so you guys can try to plug that in.
You have to, remember.
So if P is negative 3, what's that first number?
Negative 12.
Negative 12. X
Minus 1.
equals Y.
Minus 5.
Where do we get the negative 12 from? Well, P, when we divide it, yes, we got a positive 3. But because it opened to the left, that's what allowed us to make it a negative. Okay? All right, this is your last one, okay? This is your last one.
We'll have an extra space.
You will have extra space. That bottom space is supposed to be for like any type of notes you might want to take down to remember about this this section. I want you guys to try this one on your own.
Probably.
So, you need to complete the square for this one. So to do that, you need to get this over here. So hopefully you started, well, one way you could have started was by subtracting 15 over. But then, in order to complete the square term needs to be positive and it needs to be 1. So since there's a 3 there, what do you have to do with the 3? So then that's y squared plus 2y equals 4x minus 5. Now from here, you take half of b and square. What's b? When you take half of it, you get. When you square it, you get. So it's going to be y squared plus 2y plus 1, and then 4x minus 5 plus 1. How does the left factor?
Y plus 1 squared
Y plus 1 squared equals
4x minus
4x minus 4. And what do you need to do with that? Take the 4 out, which leaves you with.
x minus 1.
And you need the 4 out because what's p?
1.
1. Since my y's are being squared, this opens
Oh,
Right.
left or right. More specifically, it opens to the
Right.
because
Positive.
it's positive. P is positive, and the 4 was positive. What's my vertex?
Negative 1. Negative
1. Negative 1. It's H, K, be careful. 1, negative 1, which is right here. What's my focus? 2, negative 1, because all I do is I add P. What's my directrix?
X0.
There we go.
Yeah, I got that. I still got one back now.
So just the sum of parabolas. That one sheet, the single sheet that had the 2 formulas on it with the equations and everything, that's important. That's key. That should go on page 61. Okay? 62 should go all the examples. All right? Remember, completing the square, if it's not in the vertex form, that's that standard form there. Remember, P is the distance the focus is from the vertex, or the directrix is from the vertex. And make sure you look to see where exactly H is and where K is, so you don't get them backwards, okay?